Um, we thank God we are together in the year 2022, and we kindly ask you to subscribe to our channel, Teacher Edward Commercial Staff, so that once we upload a video, you will get a notification. So today is the 30th of January, and it's not a mistake to be alive in the year 2022, and hopefully we are going to help each other big time. So today, let's now talk physics. We want to talk the laws, the Newton laws of motion. So basically, we've got three laws of Newton, right? And we know from everyday experience, we know an object cannot move unless a force is applied on it. Way back in the 1600s, there was a scientist who was called Galileo. In fact, let's do this. Let's write today's date. Today is Monday. We are just beginning the week. Monday, 03 January 2022. And then we are doing Newton laws of motion. Right. So we are saying in the early 1600s, there was this scientist who was called Galileo. Right. He made some observations, and these observations they were later progressed by Isaac Newton, the father of classical physics. Right. So from Galileo observations, Newton then formed the laws of motion and the universal laws of gravitation. I'm sure it was around 1687. And then also there was Albert Einstein, who also formulated new laws in, this was now in the 20th century, around 1905. So there is a relationship between motion and the forces that also cause motion, and we call this one dynamics. And again, there is a relationship between dynamics and machines. And in science, we consider a machine to be a device that actually make our work easier. So after the end of this session, you should be able to define the Newton 3 laws of motion and explain what inertia is and how is it actually related to what? To mass. So inertia is that tendency of a body to maintain its state of rest or constant motion in a straight line. That is what we call inertia. And the father of physics, Newton, he actually used the term mass for the quantity of matter of an object. So usually we can say we want to now talk about the first law of Newton, the first law of motion of Newton. That's the law that we want to start discussing about. Right. So we want to start with an example. Right. For example, I'm having, this is a Bible, right? And I'm putting this Bible here, right? So the first Newton law, it says an object, any object, right? An object will remain at rest or continue to move at a constant velocity in a straight line unless an external net force acts on it. Right. So what we are trying to explain is like the first Newton law. It tells us what happens to a body, right, in the absence of force. So we are saying, let's take an example of this Bible, right? This Bible will remain where it is, right? It will not move unless there is a force that is exerted on it. So this Bible will remain at rest, right? Unless if there is a force that is applied on it, right? Or if it was moving, right, it will continue to move at a constant velocity in a straight line unless if there is a net force that acts on what? On it. So we are saying it is only a force that can make an object to accelerate. And the object, it accelerates in the direction that the force is being exerted. So it means the stronger the force, right, acting on the object, the greater the acceleration. For example, now, I take this Bible, right. If I start to exert a force, you see, the Bible is now what? Is now moving. Right. And then again, if I exert a very big force, you see, the Bible moves what? It accelerates fast. So we are saying that acceleration, and the acceleration is represented by A, right? A is produced by a force. And we say A is proportional to what? To F, right? And we can even plot a diagram, right, whereby this is the y-axis and this is the x-axis. So we say this is acceleration and this is force, and we say it's directly proportional, right? So we are saying acceleration is directly proportional to the force which produces it, meaning that when we double the force, we'll produce twice the acceleration. And if you apply 3 times the force, we will produce 3 times the what? The acceleration. Hey, it's a windy day. Right. So now we want to also talk about the third, right? The second Newton's law of motion. So the first one, I want you to be very clear. Right? We said an object will remain at rest or continue to move at a constant velocity in a straight line unless an external net force acts on it. Right. On the second now, when a net force, so like let's now write what? The second law of motion, Newton. Right. We are saying when a net force, right, is exerted on an object, it causes the object to accelerate in the direction of the force. Right. And we say this acceleration is directly proportional to the what? The force. And is inversely proportional to the what? To the mass of the object. Right. So there is another force that also influences an object's acceleration, and it is its mass. That is why sometimes even if you try to push, right, something, if that thing is heavy, it's very difficult to actually displace. So if a constant force is applied, right, the greater the mass of the object, the smaller its acceleration, right? So even if you're applying a force to something, if that object is very heavy, it's very difficult to actually move it. That is why you see it's very difficult to move a big rock, you see, because of its mass. For example, I was giving an example that this one I can push it, but the desk where I am, I can't push it because the mass is too much. You understand? Right. So we say the acceleration of the object produced by force is inversely proportional to the mass of the object. And we can write it, the acceleration is inversely proportional to the mass. Right. We write it like this, is inversely proportional to the what? To the mass. So that's the relationship between acceleration and force and acceleration and mass, right? And then from there, so we are saying since acceleration is inversely proportional to the mass, like what we said, right, is doubling the mass of the object, will have the acceleration in the force remains constant. And when we are dealing with force, we use newtons. And this was named after the father of physics, Isaac Newton. And 1 Newton is the force that will give a mass of 1 kilogram, acceleration of 1 meter per second squared. So we are saying 1 Newton, right, is equals to 1 kilogram, right, of 1 meter per second squared, right? And these quantities, they are related by the formula F. Force is equals to mass times acceleration, right? So we can use this formula to calculate different scenarios, right? We can use these calculations, the first law of Newton and the second law of Newton, to do some calculations, right? So that's what you have to understand about the first law and what, and this second law of what, of Newton, right? And the other thing again that we want to discuss about is the Newton's third law, right? The second law, like what we said, it's all about the net force. That's the second law. It's all about what? The net force, the second law, right? Whereby if we apply a net force, an object, we cause an object to actually move, right? However, now the third law of Newton, the Newton's third law, right? It states that if an object A exerts a force on object B, B will exert an equal but opposite force on A, right? For example, I can give an example whereby if I can actually go and exert a force on this zero, what is happening is like this is now an action reaction force, whereby my hand is exerting a force on the wall, and at the same time there is a reaction, you understand, of the wall. It's also exerting a force to what? To me, you understand. So that's what Newton was trying to explain when he was explaining his third law of motion. He was saying if object A exerts a force on object B, B will exert an equal but opposite force on A. And we say A and B are an action-reaction pair. I'm sure I tried to make it clear. The action is the force that B exerts on A, and the reaction is the force that A exerts on what? On B. So I'm saying like I've exerted a pressure on that, right? And the wall will also exert the same, but it's now opposite. So when the dural doesn't move, it means the forces are in equilibrium, right? So we are saying the Newton's first and second laws are linked. They concern one object, but the forces and the forces that act on it. But then the third law is different from the first and the second, in that it defines forces between two different objects. So these are some of the things that you are supposed to know when we are dealing with these Newton's laws, right? And again, the other thing that I would like to discuss is force. I'm sure we've been talking about a force pushing and pulling, right? So a force can be described as any kind of push or a pull of an object. For example, when I get into a shop, right, and then I push a supermarket trolley, right, you are exerting a force on it, right? Sometimes an object will not move when it's pushed, right? For example, you can go and push a large truck. It won't move. It might not move, you see, just because the force that you are applying is equal to the force that the truck is exerting back to you. You know, we have been talking about this action reaction pair, right? And again, the magnitude of the force can be measured with a spring scale, which is also called the Newton. And we have got the Newton meter. And we've got different types of forces, right? The pushing and the pulling, these are some examples of forces. And then we've got what, again, when we are dealing with these Newton laws of motion, we've got what we call friction, right? And friction, this is the force that makes an object to slow down. For example, you see, if you roll a ball on a surface, right, the ball will start moving fast and then later on it will slow down. You see, it is because there is a force that is opposing, right, that movement. It usually arises when the surfaces of two solids rub over each other. So you see, the surface will be rubbing on the surfaces of the ball, right? So friction occurs in the direction opposite to the what? To the motion, right? And then there is what we call weight. Some they call it gravitational force. It is the force of gravity acting on an object. This one is usually 9.8. And then there is what we call drag. This is created when an object is moving through fluid, right? It might be air, it might be water, it might be anything. And then, so there will be friction between the object and the fluid. And this force is similar also to friction. It's also called drag. And then there is what we call upthrust. Usually this one happens when an object is placed in liquid water, whereby it floats. You know, this is that upward force experienced by an object that is placed in what? In liquid such as water, right? And this upthrust, it makes possible for certain objects to float, right? And then there is what we call the normal force. The normal force, this one, it pushes up against your weight or against your gravitational force. You know, for example, when you stand on the floor or sit on the chair, you see, these forces, like they will be like vertical forces. The gravitational will be going down, and the normal force will be going what? Up. You understand? We can also call the normal force the conduct force, right? And the other type of force that is of much interest to us is the tension. This is the force that is in a rope or in a string, right? When that thing is stretched, we call it the tensional force. And then there's what we call balanced forces or equilibrium forces. For example, I was trying to demonstrate my example of on the dural there, right? But then when we are talking about balanced forces, these ones, they will not make object moves. You see, they might make the object change shape. For example, if I take a balloon, right, and I squeeze the balloon by pushing it hard on either side. You see, if I push the balloon on either side, the forces of both hands are actually balanced, right? The balloon does not move, but it can only change shape. It means like these objects are stationary, right? Doesn't necessarily mean that there are no forces that are acting on it, right? The forces will be there. Even like, for example, the Bible that I've showed you, right? It's stationary there, but then doesn't mean that there are no forces that are acting there. The forces are actually there, but what is happening is like the force, the contact force is equal to the what? The gravitational force. So basically, that's what you're expected to know, right, on these Newton's first law, second law, and third law. This is for the grade course. As we are starting this year, this is a very beneficial lesson. You have to be able to know all the three laws, Newton's laws of motion. Thank you. Don't forget to subscribe and to share and to also like.